So in this question, it specifically said that to use the method of variation of parameter. So the question is, instead of, if the question doesn't mention which method for you to use, can you use the UC method? The answer is yes, because the right hand side of the equation, our function f of x is given by exponential of x. So if the question doesn't state what method to use, for example, it just says solve this following equation. So you have two ways. You can either solve this by using UC, you can also use the VOP method. So which one is easier? I would say the undetermined coefficient is going to be easier. Okay, so but if the question specifically mentioned that you have to use VOP, then yes, you have no choices, so you have to use VOP because we are trying to assess you on that particular method. Alright, so now I'm going to start with the calculation. So I'm going to find the step number 1 is finding the YC. So my characteristic equation is going to be m squared minus 2m plus 1 equals 0. And this is going to be for the case of equal roots, because when I factorize, I will get m plus 1 square equal 0. That my roots is going to be 1. Okay, so therefore when I write down my YC of t, so that will be given by a plus b. So my independent variable is x, so I'm going to have a plus bx exponential of 1x. And before you determine y1 and y2, expand this first. So that will be the case for equal roots and also complex root. They have brackets, so please expand the brackets first. So I will get a exponential of x, so plus bx exponential of x. And from here, I can determine that my y1 is going to be exponential of x by dropping a, and my y2 is going to be x exponential of x. So that is going to be y1 and also y2. So now that I already have identified y1 and y2, so I'm going to proceed to step number 2, so which is differentiating them. So y1 is given by exponential of x, and y2 is going to be given by x exponential of x. Just drop the constant a and b. So now when I differentiate my y1, I will get exponential of x. When I differentiate y2, I'm going to have to use product rule, because here I have product of x being multiplied by exponential of x, and I have more than one x. Automatically I have to use product rule, the u and v. And I know that by using product rule, so I'm going to end up with exponential of x multiplied by x plus 1. That will be the outcome. So I'll get x exponential of x plus exponential of x. So try that yourself. You figure out that you will get this when you factorize the exponential. Okay, and now that I already have the y1 and y2 prime, so there's a prime right there, so I can put them together, and I'm going to use this to find the Wronskian. All you have to do for Wronskian is that rearrange them according to this. Okay, so if you notice what happened is that at the top we're going to have the function y1 and y2, so at the bottom is going to be the derivative of both of them. Okay, so now the Wronskian is going to equal, so here I'm going to have exponential of x, and this is going to be x exponential of x, and exponential of x multiplied by x plus 1. Okay, so let's do the calculation over here. Remember, the formula is going to be a multiplied by d, so the first element is going to be multiplied by the last element. And remember, we have exponential rules that state that if I have exponential of a multiplied by exponential of b, so it's going to be exponential of a plus b. For this case, this is my a and this is my b. So when I multiply them both, I'm going to have exponential of 2x multiplied by x plus 1. That's my ad. So minus the bc is going to be x exponential of 2x. And I know that when I simplify this, so the fact that these two, they're going to cancel each other, so in C. So what happens is that you end up with one simple term, so which is going to be exponential of 2x. So please simplify your Wronskian. So make sure that you get only one term, then only you proceed to step number 4. So now let's proceed to step number 4. So I'm going to have two elements for me to find, so which is going to be the u and the v. So u is given by negative integration of y2 fx over aw dx. So now let's substitute. So I'm going to have negative integration of y2. So what is my y2? So my y2 is given by x exponential of x. And what is going to be the f of x? Remember, so f of x is going to be the right hand side of the equation. So this is my function f of x, and that is given by exponential of x And what is my a value? A is going to be the coefficient of the second derivative. For this case, my a value is going to equal 1. Okay, so here I'm going to have 1 and the Wronskian from our calculation. So that is going to equal exponential of 2x dx. Now let's simplify this. So I'm going to end up with negative integration of x. At the top is going to be exponential to x. At the bottom is going to be exponential to x dx. And this is going to cancel. And I will end up with negative integration of x is going to be negative of x squared over 2 plus c. So that will be the outcome. So that is going to be my u function. Okay, how complicated it is going to depend on your function. Like if it's a simple function like this, so it wouldn't be that complicated, and our integration is going to be simple as well. And then I'm going to proceed to v. So v is going to be, this is the formula, integration of y1 fx over aw dx. And when I substitute, I'll end up with integration of y1. What is my y1? So that is going to be exponential of x. My f of x is going to be the same as previous. It's still going to be exponential of x. My a value is going to equal 1. And my Wronskian is going to be exponential of 2x. And I know that what happened is that these two are going to be exponential to x. It's going to cancel with exponential to x at the bottom. So I'm going to end up with a very simple integration, which is integration of 1 dx, which is going to give us x plus integration constant. Let me highlight to you the effect of the integration constant. So previously, I have already used c as my integration constant. So therefore, for my function v, I'm going to use another alphabet. So that is going to be d. So choose any alphabet from c until z, anything. Just make sure that your integration constant for u and v do not overlap. Do not choose the same alphabets for them. Okay, so we are done. Step number 5 is just putting them together. Write the solution. So my y of x is going to equal u y1 plus v y2. So now let me put them together. So my u function is given by negative x squared over 2 plus c. And I'm going to multiply this by y1, which is going to be exponential of x. And my v is going to be given by x plus d. So multiplied by x exponential of x. Okay, the rule is that should you simplify this, so the answer is going to be something like this. So if you can simplify the solution, this function, you can simplify, please simplify them, expand and simplify. However, if you cannot simply leave it like this, for example, this one, you can simplify them. So therefore, I'm going to simplify. So what happened is that when I multiplied both of this, where's the right one? Here, I'll end up with x squared exponential of x, and this 2 is also going to be x squared exponential of x, but this is going to be 1, this is going to be 1/2. So when I simplify, I will get 1 minus half, that is going to be a half, x squared exponential of x plus c exponential of x plus dx exponential of x. So that will be the solution. And similarly, to the case of what do you call that, undetermined coefficient. So there are going to be two types of solution, general and particular. So this is going to be the general solution because the answer is in terms of c and d. But if the question asks you to find for particular solution, all you have to do is substitute the initial conditions and find the value of c and d. The idea is going to be the same as undetermined coefficient. Okay. So now I'm going to show you the second example. This is going to be a little bit more complicated than the one that we have seen previously. So I'm going to solve an equation that involves a trigonometric function, which is cosecant of t. So I have d squared y over dt squared plus y equal cosecant of t. So what is cosecant of t? So cosecant of t is actually 1 over sine of t. So this question over here, so previous one, it stated exactly that you have to use VOP. But this one, it doesn't state which method for you to use. So the question is that, can you use UC for this? The answer is no. You cannot use UC for this because remember, you can only use undetermined coefficient if it's a sine or cos. 1 over sine, 1 over cos is a no. Okay, so it's strictly only for sine and cos. So that is why for this particular question, even if it doesn't state that you have to use VOP, because we cannot use UC, you have no other choice. You have to know right away that the only way of solving will be the VOP. So now let's start our calculation. So step number 1 is going to be the characteristic equation. So m squared plus 1 is going to equal 0. And for this case, I will get m equal plus minus of I. And for this case, we know that alpha is going to equal 0 and beta is going to equal 1. So this is going to be a case of complex root. So my yc of t, be careful. So here my variable is y and t. So I'm going to get yc of t is going to equal exponential of 0t. That is going to be exponential of, this is going to be 1. Then I'm going to have a cos of 1t. So plus b sine of 1t. So that is going to be my yc. So it's going to be a cos t plus b sine t. And of course, from here right away, we can identify what is going to be y1 and y2. So my y1 is going to be given by cos of t, and y2 is going to be given by sine of t. So I'm going to proceed to step number 2. Okay, so now I'm going to write right here. So the fact that my y1 is given by cos of t and y2 is going to be given by sine of t. So I'm going to find the derivative of both of them. So cos is going to be negative of sine and sine is going to be cos. Okay, so now I can find what is going to be Wronskian. So the element is going to be the same, cos of t, so negative sine of t. So here I'm going to have sine of t, and this is going to be cos of t. So when I applied AD minus BC, so I end up with cos squared t. So this is what happened when I multiplied both of this. So here I have minus and a minus, so of course that is going to be a plus, and sine multiplied by sine, that is going to be sine squared t. So let me give you tips. So every single time when you come across that your yc, your y1 and y2 is going to be in terms of sine and cos, there is going to be this one identity that you definitely will have to apply in your calculation, so which is a simple identity. So the fact that if you have sine squared theta plus cos squared theta, so this is going to be 1. So on the condition that this angle must be the same. So now the angle is the same. This is cos t, cos squared t, and the other angle is also sine squared t. They are the same. So therefore, here we can simplify. So the fact that the Wronskian is going to be 1. So trust me, like every single time you do your calculation, so when you get your y1 and y2 in terms of cos and sine, you always going to have to apply this property right here. Okay, so it's a good idea for you to remember this, and I'm pretty sure you do, because this is something that we have come across since like school years. Okay, so it's a very common identity, that sine squared theta plus cos squared theta, so that is going to equal 1. Alright, so now I'm going to start calculating u. So u is going to be negative integration of y2, so which is given by sine of t multiplied by f of t. My f of t is given by cosecant of t, which is 1 over sine t. And my a value is going to equal 1, and my omega value is also going to equal 1. And this is going to be very simple integration, so those two are going to cancel. And I'll end up with negative t plus integration constant c. So that is going to be my first function. And then I'm going to have v. So v is going to equal integration of y1, so which is given by cos of t, so multiplied by 1 over sine of t, and that is going to be over 1 multiplied by 1 dt. So basically, if I simplify this, I'll put it in a better form. So it's going to be integration of cos t over sine of t dt. So when you have a look at this, straight away you should be able to tell that this is going to be integration by substitution. Why is it integration by substitution? Because when I differentiate the bottom, I will get cos of t. So that is integration by substitution. That is the indicator. So here I'm going to let u equal sine of t. So my du over dt, that is going to equal cos of t. So my integration is going to be transformed to integration of cos of t. So now sine t is going to be u, and what is dt? So dt is going to be du over cos of t. Okay, so this and this is going to cancel. So I have an integration of 1 over u du, so which is going to equal log of u, and I know that my u is going to be sine of t, and this is going to be plus t, right? So that is how it's going to look like. So that is going to be my v function. Okay, so now that I already have all the components together, so I can write down the solution. So my y of t is going to equal u, so which is negative t plus c multiplied by y1, so that is going to be cos of t, plus v, so which is log of sine of t plus d, and that is going to be multiplied by sine of t. Now, remember the rule, if you can simplify, expand and simplify. If you cannot, leave it like this. And for this case, I don't think I can, because this is going to be t cos t. This is log sine t sine, so there's no way that I can simplify this, so therefore I'm just going to leave it like this, and this is going to be our solution. And of course, as usual, I'm going to prepare a bunch of exercises for you to try, so have a go at them. And please, instead of using the method that you have in the book, this one is going to be so much easier. All right.